Today we'll be talking about Unit 6 Biomechanics numerical model, and the numerical model is broken into three different main categories, which are linear motion, angular motion, and projectile motion. In this PowerPoint we'll mainly be focusing on linear motion, which consists of scalars and vectors. Now these two words may sound very foreign to you, but scalars are essentially speed, acceleration, and distance, whereas vectors are velocity, acceleration, and displacement. We'll talk about each of these categories in more detail later on in the PowerPoint. So the first two we're going to talk about are this distance and displacement. Now, distance and displacement are quite similar. The distance is mainly is how far the line has traveled. So it doesn't matter any given direction. So it could be in any direction literally. So it's basically the sum of all movements regardless of direction. Now displacement on the other hand is the distance between from point A to point B in a straight line. So an example of displacement is a 100-meter sprint, and an example of distance, measuring distance, would be a marathon race or even a 400-meter. Because you're not moving in a straight line, you cannot measure displacement in those races. Also, the scalars and vectors are divided up into speed and velocity. Speed is basically how fast something moves in any given direction. So it's how quickly your body moves, and it can be measured in meters per second. This is distance divided by time. It is basically used to measure stuff like RP, like cars, used in cars, more short than velocity, because it could be in any given direction. Um, Velocity, on the other hand, is the opposite. It is still speed, but it's in one direction. So basically, it's measured in the same measurement, meters per second, but instead of the equation being distance divided by time, it is displacement divided by time. So remember, displacement is a straight line, whereas distance can be in any given direction. Um, Now, yes, all of these things are hunky dory, but there's also to consider speed, time, displacement, all that. We must also think about Newton's laws. Now, Isaac Newton came up with three main laws, which were inertia, acceleration, action, reaction. These all are to do with the laws of motion and gravity, and explains how we move, why we move, and when we move. Inertia is basically the stage of when an object is resistant to change. So it's in a particular position, and it can it can be moving at a constant velocity, or it can even be still. Once it's constant and changing, it is seen as inertia. So an example of this maybe is as you can see in the picture, the rugby ball before it's getting kicked for a try. Um, it will stay there. It will stay in that position until it gets kicked, until something else moves it, or until it's overpowered by a force. Now, see now when this happens, when a force overpowers its inertia, then it creates an acceleration. So when that rugby player kicks the ball, it will now move off that object and start to propel itself forward, because the force created by the rugby player is greater than what it was originally having, which caused inertia. So that moves on to the second law, which is acceleration. This only occurs when a mass is overpowered by a force. This is usually in this law. The more the force, the faster the object will accelerate. So if you imagine two different people, as we can see in this picture, now if they had to be both stand in a straight line preparing for a 100-meter sprint, and they were both given the same amount of propulsion force or force, they would move in the exact same. The heavier object would take more force to move as fast as the lighter object. So the lighter object would move faster because it's less weight, and although it's the same force, the less weight helps it to move faster. Um, so basically, another example of this maybe would be throwing a shot put. So if the shot is heavier than the force you throw it, the same as the lighter one will go further, and it would take more of a force to make the heavier one go further. The third law is action and reaction. This is quite a practical one. So if you imagine hitting an object or pushing an object, the same force you apply to an object to change its direction or to make it accelerate is the same force you receive back. So when you hit a tennis ball or you hit a baseball, as you can see in the picture, when you hit that ball, you receive the same force back. And some of you might be thinking, well, the ball goes really far, and my body doesn't go that far. But because of the weight of our body and the control of our muscles, we can control that force that we receive, whereas the ball can't because we overpower it so much. But we still do receive the same amount of force. Moving on to the next slide, we can see that we're going to talk about center of mass and stability. So some of you might ask, what is mass and what is stability? Now stability, we're going to talk about stability first. Stability relates to how difficult it is to disturb a body from a balanced position. So if you imagine someone standing upright with their legs together, they will be less stable than someone if they open their legs to shoulder width, or whatever the case may be. Also, so stability is made up of three different parts, which is the center of mass, the line of gravity, and the base of support. The base of support is what helps you to be more stable. The wider the base of support, or like for your legs, for example, the more stable you're supposed to be. If this is because if you imagine like a pencil, for example, when you place it on its rubber, it will fall over because it does not have that much stability because it has such a small base of support. But if you were to place a bottle cap, for example, it has a wide base of support, so it's therefore it's more stable and less likely to topple over. Also, the center of mass is where the middle of our body is, where complete balance is. In an object, if you were to have a circular, like a ball or some type of object, like a sphere, it would be, if when you put it on the floor, eventually it'll stop rolling, and the point at which it stops rolling is where its center of mass is. And the line of gravity is basically the line between the center of mass through the body to the base of the support. We can increase stability by four main things. This could be by lowering the center of mass, keeping the line of gravity within the base of support, so don't let it go outside the body. Like bending over, you'll be less stable. If you keep upright, you'll be more stable. Also widening the base of support, as we talked about earlier, and this creates more points of contact, so it makes you a lot more stable than if you had less points of contact. To make instability, it's basically just the opposite now. So if you make the center of mass outside your body, or you decrease the length of your base of support, that'll make you more unstable. So, for example, cartwheeling or standing on one foot make you a lot more unstable because your center of mass is outside your body. Next, we're going to talk about mass in itself, and the definition of mass is the amount of material which an object is made of. So that could be it's everything that makes your body heavy, all the systems in your body plus the gravitational pull. That's how heavy. So it's basically how heavy an object is. The center of mass, on the other hand, is the point at which the body is balanced in directions, as I said earlier, in stability. This has an effect on gravity because gravity is pulling you down constantly. So if we didn't have any gravity, we'd be floating through the air, and gravity will act down through the center of mass. So if it's in our belly button and we stand straight, the gravity will always have that constant pull down towards the base of support or down towards the ground. Um, the if so because we have a center of mass at all times, it can change all the time. It will change because we're moving. So in the pictures at the bottom, we can see that the woman on in the left is standing upright, and her center of mass is in her by her belly button area. Now that would mean that she's most stable there. But if she were to be a ballerina and perform one of those advanced techniques, her center of mass may be outside the body. So when our limbs leave our general center of mass, their central position, it causes the body to become unstable and it will change the center of mass. Also, if we start on one foot, we have to balance, we have to try to keep upright. The center of mass will slightly move to the left or slightly move to the right depending on the distribution of weight. Well, thanks for listening, guys. Um, Next time we'll look at the methods of biomechanics in biomechanics.